Hello, everyone. Welcome back. Today, we are going to be identifying arithmetic and geometric sequences. So, how do we know whether a series is arithmetic, geometric, or neither? Well, the key characteristic is that arithmetic sequences have a common difference. That means that the difference between any one term to the next is the same throughout the entire sequence. So, for example, 1, 2, 3, 4, 5 is an arithmetic sequence because every time we have a term, in order to get to the next term, we add 1, right? We add 1 to get to 2, then we add 1 to get to 3, then we add 1 to get to 4, and so on. Another example is 100, 90, 80, 70, 60, 50, etc. Because in this case, we always add negative 10. And so the common difference is negative 10. Another way we can look at this is, subtracting, right? We subtract 10 each time, which is the same as adding a negative number. And that's also something we might have in the sequence as well, as we might be adding a negative number, hence subtracting in order to get to the next term. But that's the key characteristic, right? If in order to get from one term to the next, we add or subtract the same number every time, then it's an arithmetic sequence. And if that is not the case, then we do not have an arithmetic sequence. Okay, let's talk about geometric sequences. Geometric sequences have a common ratio, or in other words, a common number that we multiply. Now, this number can be just a regular, whole number or integer, or it also could be a fraction. And so dividing, in a way, since fractions are kind of like division in terms of how they play out, if we're dividing by a certain number, we're really just multiplying by the reciprocal, and therefore that would work too. So I'll give a couple examples here. Here we have 12, 24, 48, 96. So here we start at 12, and then in order to get to the next term, we multiply the previous term by 2. So this is an example of a geometric sequence for that reason. The second one here, you might notice we do 200, 150, 25, 12.5, and so on. And so each time we divide by 2. And recall that that's the same thing as multiplying by 1/2. So 1/2 is our common ratio that we would do. All right, so let's get into some examples. We're going to identify whether each of these sequences is arithmetic, geometric, or neither. Okay, so this first one, 2, 4, 6, 8, 10, 12. Well, this would be arithmetic because the common difference is 2, right? No matter which term I choose, in order to get to the next one, we add 2. The second one, 2, 4, 8, 16, 32, 64, is geometric because it has a common ratio. Notice that to get from one term to the next, we always multiply by 2 every time. And so, therefore, it must be geometric. C is a bit trickier. So this one can't be arithmetic, and here's why. Because it goes up and down, right? And with an arithmetic sequence, it either always goes up every time or always goes down every time. Whereas this switches from positive to negative numbers, so therefore it definitely can't be an arithmetic sequence. But what about geometric? Well, the thing is with geometric is that we can divide 64 by negative 4, right? Or multiply it by negative 1/4 to get negative 16. We can multiply this by negative 1/4 again to get 4. And then we can multiply 4 by negative 1/4 again to get negative 1. Right? And so if all we have to do is just keep multiplying by negative 1/4 to get the next term. Therefore, this is a geometric sequence because it has a common ratio of negative 1/4. Okay, now what about this next one here? 1, 1, 2, 3, 5, 8. Well, let's first look at, could it be arithmetic? Well, no, it couldn't be, because notice to get from 1 to 1, we would add 0. To get from 1 to 2, we add 1, and then we add 1 again, then we add 2, And then we add 3. And so if we just look at it in terms of numbers we're adding, which may or may not even be the pattern, right? Which in this case it isn't, but that's not really the point. The point is that in this situation, we're not just adding the same number each time, we're adding different numbers to get to the next term. So it can't be arithmetic. It also can't be geometric, right? Because if we're going to go from 1 to 1, we have to multiply by 1. To get from 1 to 2, we multiply by 2. To get from 2 to 3, we're going to be multiplying by a fraction, I think like 1.5 or something, right? Times 1.5, and so on, right? So the point is, these numbers are all different. In fact, even after we get to this point and notice that, that 1 and 2 are different, right? These are different. We can recognize that it can't be geometric because there is no common ratio. And so this would be neither, this sequence here. Okay, then we have E, 6, 2, -2, -6, -10. Well, it looks like we add -4 every time, or subtract 4 every time, in other words. And so therefore, because we always take every term and subtract 4 to get the next, therefore this would be arithmetic, because there is a common difference of -4. And there we go.